Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are fine at home. Today, our topic of study is phenols, and we will study different methods for the preparation of phenols. There are so many methods, but out of that, we will study only four methods for the preparation of phenol. The first one method is preparation of phenols by fusion of sodium benzene sulfonate with alkali. Second method is hydrolysis of chlorobenzene. And third method is oxidation of thymine. And fourth method is hydrolysis of aryl diazonium salts. Now, the first method for the preparation of phenol is from fusion of sodium benzene sulfonate with alkali. Now, this sodium benzene sulfonate is not already present as a natural compound. We have to prepare this sodium benzene sulfonate, and this is the first synthetic method for the commercial preparation of phenol and was developed in 1890, and it involves sulfonation of benzene followed by fusion of the sodium salt of benzene sulfonic acid with sodium hydroxide. Now, in this method, first of all, we will prepare benzene sulfonic acid, and this benzene sulfonic acid is prepared by sulfonation of benzene. And sulfonation of benzene is carried out when we treat benzene with concentrated sulfuric acid at almost 80 degrees centigrade. Benzene is converted into benzene sulfonic acid. Now, this benzene sulfonic acid on treatment with sodium hydroxide at 350 degree centigrade, first this is converted into sodium salt of benzene sulfonic acid. Benzene sulfonic acid is first converted into sodium salt of benzene sulfonic acid, that is, this hydrogen is replaced by sodium ion, and this sodium benzene sulfonate, that is written fusion of sodium benzene sulfonate, is then fused with sodium hydroxide again, and this is converted into sodium salt of phenol. This is converted into sodium salt of phenol, and this sodium salt of phenol then on acidic hydrolysis is converted into phenol. So actually this is the fusion of sodium benzene sulfonate with alkali. This benzene sulfonic acid when treated with sodium hydroxide is first converted into sodium benzene sulfonate. This hydrogen is replaced by sodium, and this is then known as sodium benzene sulfonate. And this sodium benzene sulfonate then fusion with sodium hydroxide is converted to sodium salt of phenol, and this sodium salt of phenol then treatment with hydrolysis in the presence of acid is converted into phenol. If we have any salt of an acid, we hydrolyze it in the presence of small amount of acid, this is converted into that acid. So this process can also be used in the laboratory, but due to vigorous conditions. What are the vigorous conditions? That is 350 degree centigrade temperature, that is a high temperature. So this method cannot be used for those phenols which have already another group on benzene ring that can be destroyed at this high temperature. So for that, we can use another method, and the other method is we will use mixture of sodium hydroxide and potassium hydroxide. When we use mixture of sodium hydroxide 70% and 30% potassium hydroxide for the fusion of sodium benzene sulfonate, the reaction is carried out at somewhat a low temperature, that is 300 centigrade. This is the same method as this one, that is the fusion of sodium benzene sulfonate with alkali. In this method, we will use two alkalis, that is sodium hydroxide 70% and potassium hydroxide 30%. Then this reaction will be carried out at a lower temperature, that is 300 centigrade, and this sodium benzene sulfonate is converted into sodium salt of phenol. Here is another group already present, that is methyl group at para position to this sulfonic acid group. This group will be present as such in the product, just this group, that is sodium benzene sulfonate. This is converted into sodium salt of phenol, and this sodium salt of phenol on acidic hydrolysis is converted into phenolic group, just like that reaction that was in the first method. Sodium salt of phenol on hydrolysis, acidic hydrolysis is converted into phenol. Now, this is paramethyl phenol, and paramethyl phenol is known by its common name, that is cresol. If methyl group and OH group are present on benzene ring, it's known as cresol, and these two groups are at para position, so it's known as para cresol. So this process is generally used for the preparation of alpha and beta naphthols. Alpha and beta naphthol means when OH group is present on naphthalene. When OH group is present on naphthalene, then this is not known as phenol, this is known as naphthol. If OH is present at one position of naphthalene, this is alpha naphthol, and if OH is present at two position of naphthalene, it's known as beta naphthol. Then it's known as then it can be used for the preparation of resorcinol. Resorcinol is meta dihydroxybenzene. If two OH groups are present at meta position, then this is resorcinol, and it can also be used for the preparation of meta hydroxybenzoic acid. Meta hydroxybenzoic acid, that is, if benzoic acid group is present, carboxylic acid group is present on benzene ring at meta position, we can introduce OH group by this method, and 3,5 dihydroxybenzoic acid can also be prepared by this method. Now, the next method for the preparation of phenol is by hydrolysis of chlorobenzene. And this process was developed by a company that was known as Dow Chemical Company in 1928, and hence this is known as Dow process by the name of company who developed this method. And in this process, what we have to do, we will do hydrolysis of chlorobenzene with 10% solution of sodium hydroxide. But chlorobenzene is not present naturally. We have to first prepare chlorobenzene, and this chlorobenzene can be prepared by halogenation of benzene. And halogenation of benzene is carried out by treatment of benzene with chlorine in the presence of Lewis acid catalyst, that is ferric chloride, FeCl3, or aluminum chloride may also be used in this process. In case of halogenation of benzene, we use Lewis acid catalyst, which in the mechanism creates a strong electrophile chloronium ion. In this way, benzene is converted into chlorobenzene along with HCl is formed, that is a side product and not written here. Now, this chlorobenzene on hydrolysis with aqueous sodium hydroxide at 360 degrees centigrade and at 300 atmospheric pressure is first one converted into sodium salt of phenol. Sodium salt of this sodium salt of phenol on treatment with HCl or hydrolysis in the presence of small amount of acid is converted into phenol. This step is same as was in the first method, that sodium salt of phenol on acidic hydrolysis is converted into phenol. This is a general reaction for the preparation of phenol from chlorobenzene. First, we will prepare chlorobenzene from benzene by treatment with chlorine in the presence of Lewis acid catalyst. Chlorobenzene is prepared, and this chlorobenzene is then hydrolyzed with 10% aqueous sodium hydroxide at 360 centigrade and 300 atmospheric pressure. This is converted into sodium salt of phenol, and the sodium salt of phenol on acidic hydrolysis is converted into phenol. Now, after this general reaction, we will study its mechanism. The hydrolysis of chlorobenzene probably involves, not confirmed, but probably it involves benzene as an intermediate in the mechanism. In first step, base, that is hydroxyline, removes protons from carbon that is adjacent to that carbon to which chlorine is attached. This proton is removed from here, and these two electrons goes here and forms a bond with this carbon, and this chloride is removed from here. Now, OH when combines with H positive will form water molecule, and here when triple bond comes, then this is known as benzene because there is triple bond. So now this is known as benzene. Water is formed and chloride is removed from the benzene ring. Now, in next step, this hydroxyl line again attacks on benzene ring, and this bond is shifted towards this carbon. So this carbon acquires a negative charge. OH attacks here, and this carbon is negative. Now this negative carbon needs one proton, and that proton it takes from water molecule that was formed by OH and H positive. It takes proton from here and is converted into phenol along with OH negative ions that was used as a catalyst that is regenerated at the end of reaction, and so this phenol is formed. So this is very important method that was known as dough process for the preparation of phenol from chlorobenzene, and also known as hydrolysis of chlorobenzene. Now, what's limitation about this method? This is not suitable for the laboratory use because of the involvement of the benzyne intermediate, and this benzyne intermediate this is not suitable because this benzyne intermediate may lead to the formation of a mixture of isomeric product. When there will be formed mixture of isomeric product, if on this benzyne that is formed as an intermediate, if here is another group already present on benzene ring, then OH group may come to this position and it may come to this position. If it comes to this position, then ortho product will be formed or ortho isomer is formed. And if the OH group is attached to this position, then meta product will be formed. And in some cases, ortho and para products may be formed. So it's not a suitable method when a group is already present on benzene ring and we want to form a phenol from it. So it can only be used when there is no group already present on benzene ring. This is a good method for the preparation of phenols when there is a strong electron withdrawing group already present at the benzene ring. Electron withdrawing groups are those groups which uh, attracts electrons towards themselves from benzene ring. Now, nitro group is a strong electron withdrawing group. When nitro group is present on benzene ring, it withdraws electrons, and any nucleophile can come to benzene ring and can attack on benzene ring. And when this nucleophile is basic group, that is when we treat this compound which have a chloride on it already present. This is chloride that is present on benzene ring, and three nitro groups are present on this benzene ring. Now, these nitro groups are strong electron withdrawing groups. So, they withdraw electrons, and here is deficiency of electrons. So, OH group from hydroxyl group from sodium hydroxide can attack on this position, and when it will attack on this position it has negative charge on it. This negative charge will come to ortho position, and then it may be delocalized to para position and then to other ortho position. So this delocalization is shown by this half circle along with negative sign in the center. It means this negative charge which comes from this OH group can be delocalized to whole of the ring, and at the end uh, this chloride ion removes from here along with its electron pairs, and this negative charge is again converted into pi sheath of electron that is delocalized pi electrons, and chloride is removed from here and this phenol is formed. Now in this case phenol is formed but by another mechanism. This is not similar to the formation of benzene. Okay, this method is followed when there is a strong electron withdrawing groups present on benzene ring. Whenever strong electron withdrawing groups are present on benzene ring, this mechanism will be followed. But if electron withdrawing groups are not present on benzene ring, then hydrolysis of chlorobenzene is followed by the formation of benzyne intermediate. Now in this case, this is 2,4,6 trinitrophenol is formed. Now the third method is by oxidation of cumene. We can prepare phenol by the oxidation of cumene. This is also an important industrial process for the production of phenol, and it was developed in 1953, and it involves an air oxidation of cumene. And this is all cumene is an inexpensive hydrocarbon that is can we can prepare it from benzene and an alkene, so it's inexpensive method for the preparation of phenol. Now first we should know what is cumene. Isopropyl benzene is known as cumene. This is isopropyl benzene, and its common name is cumene. And this cumene is not present naturally. We have to prepare it, and we can prepare it from benzene by its reaction with propene. Benzene, when reacted with propene in the presence of sulfuric acid, at 250 degree centigrade temperature and a certain amount of pressure, benzene is converted into isopropyl benzene. In this process, sulfuric acid acts as a catalyst. Here mechanism is not given, but sulfuric acid protonates this carbon. Sulfuric acid protonates this carbon, and this carbon acquires positive charge, so this positive carbon attacks benzene ring and is attached to this benzene ring, and isopropyl benzene is formed, that is known as cumene. Now the method which is for the preparation of phenol is oxidation of cumene. Oxidation of cumene, and this is air oxidation, that is oxygen from air comes and at a temperature of 130 degrees centigrade. When cumene is treated, it's converted into cumene hydroperoxide, that is two oxygens come here between this carbon and hydrogen. This carbon and hydrogen इन दोनों के दरमियान में two oxygens आ जाएंगी, oxygen oxygen and then it's hydrogen, and it's known as cumene hydroperoxide. Now, this cumene hydroperoxide, when treated again with sulfuric acid at a temperature of 70 degree centigrade, this OH group comes to this carbon, and this central part is removed as acetone, and it's not such a simple but reaction, but this OH comes to this carbon after 9 to 10 steps of rearrangement. This OH comes to this carbon and phenol is formed, and the remaining part forms acetone. So it's a very important method because in this case one product is formed phenol and the second product is acetone, which is equally important as that of phenol. That is side product is also very important, that is formed in this reaction. In many cases side products are formed which are not useful or which are not so important, but in this case both these products are very important, that is phenol is important and acetone is also a very important side product that is used in so many other reactions. So the method was preparation of phenol by the oxidation of cumene. What is cumene? Cumene is isopropyl benzene, and cumene can be prepared from benzene by its reaction with propene in the presence of sulfuric acid at 250 centigrade, and this cumene on air oxidation at 130 centigrade is converted into cumene hydroperoxide, and cumene hydroperoxide on treatment with sulfuric acid at 70 degree centigrade is converted into phenol and acetone. Now the fourth method is for the preparation of phenol. Phenol can be prepared by the hydrolysis of aryl diazonium salts. Hydrolysis of aryl diazonium salts. So in this case, first we have to prepare aryl diazonium salts because aryl diazonium salts never occur in nature, but we have to prepare them. And in this case, we also prepare these aryl diazonium salts from benzene, and their hydrolysis uh, mm, gives us phenol. Now, aryl diazonium salts can be prepared by reaction of primary aromatic amines with nitric acid. Primary aromatic amines. For example, aniline, we can treat aniline with nitrous acid. But this nitrous acid is not very stable, and is not present as such in the lab, and we have to first prepare this nitrous acid. For this, the preparation of this nitrous acid, we treat sodium nitrite with HCl, which forms nitrous acid in the reaction mixture, and this nitrous acid, when treated with primary amines, gives us aryl diazonium salts. And these aryl diazonium salts are stable in cold aqueous solution, so we carry out the reaction at 0 centigrade. And when we hydrolyze them at with water, they give us phenol. Now in this case, this is aryl diazonium salt, this is aryl part, N2 positive with Cl negative. Now this is aryl diazonium salt. How we will prepare this aryl diazonium salt? We will prepare it from benzene. That is starting material. इन बच्चों देखें आप सारे रिएक्शंस में जो स्टार्टिंग मटेरियल है वो बेंजीन है, बिकॉज बेंजीन जो है वो इजीली अवेलेबल है नेचुरल प्रोडक्ट में। पेट्रोलियम से हम इसको ले सकते हैं, क्रूड ऑयल से मिल सकती है, ये फ्रैक्शनल डिस्टिलेशन ऑफ पेट्रोलियम में। सो चीप मटेरियल इस इन सब में जो स्टार्टिंग मटेरियल है वो बेंजीन है। हम बेंजीन लेंगे एंड बेंजीन की नाइट्रेशन करवाएंगे हम, एंड नाइट्रेशन ऑफ बेंजीन इज कैरिड आउट बाय ट्रीटमेंट ऑफ बेंजीन विद concentrated nitric acid in the presence of concentrated sulfuric acid. Benzene is converted into nitrobenzene. Now, this nitrobenzene is converted into aniline, and this process can be carried out when we reduce this nitrobenzene, and reduction is carried out by reaction with stannous chloride in the presence of HCl. Stannous chloride, when treated with HCl, it's converted into stannic chloride along with the evolution of nascent hydrogen. Now, this nascent hydrogen that is produced in the reaction mixture, it converts NO2 group into NH2. NO2 is converted into NH2. So the process is known as reduction. Here is removal of oxygen and addition of hydrogen. Removal of oxygen is known as reduction, and addition of hydrogen is also known as reduction. So nitrobenzene can be converted into aniline by reduction with stannous chloride and HCl. Now, this aniline is converted into aryl diazonium salts, and how it can be converted? It can be converted, aniline group can be converted into aryl diazonium salt but when we treat it with sodium nitrite and HCl. This is sodium nitrite, not nitrate. Sodium nitrite and HCl at 0 centigrade. When sodium nitrite reacts with HCl, HNO2, nitrous acid is formed, and this nitrous acid converts this aniline into aryl diazonium salt. This is aryl diazonium salt. In this compound, here is nitrogen triple bond nitrogen. So nitrogen have one bond with carbon and three bonds with other nitrogen. So it has four valency, and that's why it requires positive charge. And this chloride comes here to stabilize this compound. So it's known as salt. Aryl diazo group and triple bond N when attached with benzene ring. This is known as azo group, and this is aryl diazonium salt. Now, this aryl diazonium salt method was by hydrolysis of aryl diazonium salts. At this point, we have prepared aryl diazonium salt from benzene by its nitration nitrobenzene. Its reduction is converted into aniline, and aniline on treatment with NaNO2 and HCl is converted into aryl diazonium salt. Now, this is the last step, that is hydrolysis of aryl diazonium salts. Hydrolysis of aryl diazonium salts in the presence of small amount of acid at 100 centigrade. This aryl diazonium salt is converted into phenol along with evolution of nitrogen from here, and HCl is formed. So nitrogen and HCl are side products and phenol is formed, and it's the most satisfactory method for the preparation of phenols in the laboratory, because in this case first thing is starting material is cheap, and next temperature is very low at which we have to perform the reaction, that is in this case 0 centigrade and then 100 centigrade. So it's very satisfactory method for the preparation of phenols in the laboratory. Now the last one is if we have to prepare phenolic derivatives. Phenolic derivative means phenol along with some other groups at benzene ring, that will be known as phenolic derivative, and they are best prepared from phenols through electrophilic substitution reaction. Different types of electrophilic substitution reactions with different electrophiles we will study another lecture. So up till now we have studied four methods for the preparation of phenols. First method was by the fusion of sodium benzene sulfonate with alkali. Second method was hydrolysis of chlorobenzene. Third method was by the oxidation of suamine, and the fourth method was hydrolysis of aryl diazonium salts. So we have prepared phenols by four different methods, and these four methods are very important, and very important question from paper point of view. You have must to learn these four methods for the preparation of phenols. In all these methods, the starting material is benzene, and we have prepared from phenol from benzene by different method by converting benzene to different compounds, and then those compounds can be converted into phenol. Now next we have to study physical properties of phenols. Now there are different physical properties of phenols, that is melting points, boiling points, solubility and acidity. So first one is melting points. Students, in accordance with the general rule, there are certain rules that are set. So according to the general rules, symmetrical phenols have higher melting points than their unsymmetrical isomers. Symmetrical molecules are those molecules which can be divided into two equal halves. They are known as symmetrical, and if they cannot be converted into two equal halves, then they are known as unsymmetrical isomers. Now, the example is among the chlorophenols, para isomer has the highest melting point, and the ortho isomer is liquid at ordinary temperature. Rule is symmetrical phenols have higher melting points than unsymmetrical phenols. Para isomers are known as symmetrical isomers, and ortho and meta ortho isomers are known as unsymmetrical isomers. Now, in case of phenols, OH bond is more polar than that of alcohols. Although OH group is in alcohols and OH is in phenols, but in case of phenols, OH is more polar. The reason is that it's attached with benzene ring, and in case of benzene ring, there are pi electrons which can polarize this OH bond. So OH bond of phenols is more polar as compared to alcohols, and phenols therefore form strong hydrogen bonds than alcohols, and resulting in higher boiling points and greater solubility in water. ये अगर उनके हाइड्रोजन बॉन्डिंग एक दूसरे के साथ हो रही है फिनोल के मॉलिक्यूल्स के आपस में, तो उससे उनके बॉइलिंग पॉइंट्स हाई हो जाएंगे, और अगर वाटर के साथ उनकी हाइड्रोजन बॉन्डिंग ज्यादा स्ट्रांग हो रही है तो वाटर में उनकी सॉल्युबिलिटी भी ज्यादा हो जाएगी. इसको हम टू मॉलिक्यूल से कंपेयर कर सकते हैं. वन मॉलिक्यूल इज साइक्लोहेक्सानोल. Now the solubility of now the boiling point of cyclohexanol is 161 centigrade, and its solubility is 3.6 gram per 100 ml of water at 25 centigrade. यानी इसका बॉइलिंग पॉइंट कितना है 161 सेंटीग्रेड, और सॉलिबिलिटी कितनी है 3.6 ग्राम पर 100 ml. But the boiling point of phenol is 182 centigrade, and its solubility is 9.3 gram per 100 ml at 25 degree centigrade. Okay, boiling point 161 and solubility 3.6, but the boiling point of phenol is 182 centigrade and its solubility is 9.3 gram per 100 ml. तो फिनोल का बॉइलिंग पॉइंट भी क्यों हाई है कि इसमें हाइड्रोजन बॉन्डिंग ज्यादा स्ट्रॉन्ग है, और सॉल्युबिलिटी क्यों ज्यादा है वाटर में कि वाटर के साथ भी इसका जब हाइड्रोजन बॉन्ड बनेगा वो ज्यादा स्ट्रॉन्ग होगा, क्योंकि इसके केस में जो OH बॉन्ड है वो ज्यादा पोलर है एज कंपेयर टू सिंपल एल्कोहल्स. Now, the next is according to general rule, symmetrical molecules should have lower boiling points than the unsymmetrical molecules, but this is not the case with phenols, particularly those having an electronegative substituent ortho to the hydroxyl group. यानी अगर ऐसी phenols होंगी कि हाइड्रोक्सल ग्रुप से ऑर्थो पोजीशन पे अगर कोई इलेक्ट्रोनेगेटिव ग्रुप प्रेजेंट है, तो फिर ऐसा नहीं होगा कि जो सिमेट्रिकल है उनके लोअर बॉइलिंग पॉइंट हो और जो अनसिमेट्रिकल है उनके हायर हो. It has been seen that in many such cases, orthoisomer, despite their lack of symmetry, have boiling points much lower than their meta and para isomers. हम इसमें इनके बॉइलिंग पॉइंट्स कंपेयर कर सकते हैं. इस केस में होगा क्या कि जो ऑर्थो आइसोमर्स हैं उनमें हाइड्रोजन बॉन्डिंग ज्यादा स्ट्रॉन्ग हो जाएगी. बच्चों, जो ऑर्थो आइसोमर्स हैं उन अगर ऑर्थो पोजीशन पे इलेक्ट्रोनेगेटिव एटम है तो जो फिनोल का OH ग्रुप होगा उसका जो हाइड्रोजन होगा वो उसके साथ हाइड्रोजन बॉन्डिंग कर लेगा, स्ट्रॉन्ग हाइड्रोजन बॉन्डिंग कर लेगा, इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग हो जाएगी. और अगर इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग होगी तो मॉलिक्यूल्स पहले से ही एक दूसरे से सेपरेट होंगे और सेपरेट मॉलिक्यूल्स को बॉयल करना इजी होगा, इसलिए उनका जो बॉइलिंग पॉइंट है वो लो हो जाएगा. तो द लोअर बॉइलिंग पॉइंट, लोअर बॉइलिंग पॉइंट मींस हायर वोलेटिलिटी, मींस वो इजीली वेपर्स में कन्वर्ट हो जाएगा. ऑर्थो नाइट्रोफिनॉल का उसको हम एट्रीब्यूट कर सकते हैं किलेशन से. व्हाट इज किलेशन? इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग. And chelation of orthonitrophenol helps its separation from its meta and para isomers by steam distillation. In case of orthoisomers, there is intramolecular hydrogen bonding, but in case of meta and para isomers, intramolecular hydrogen bonding is not possible. In that case, there is intermolecular hydrogen bonding, that is between two molecules. So when there is hydrogen bonding between two molecules, it's difficult to separate them, or some amount of energy or heat is required to separate meta isomers and para isomer molecules. But in case of ortho isomers, molecules are already separate from each other because they have intramolecular hydrogen bonding, not intermolecular hydrogen bonding. So it's possible to separate orthoisomer by steam distillation. We can separate orthoisomer by steam distillation, but meta and para isomers cannot be separated by steam distillation because their boiling points are high. But the boiling point of orthoisomer is low, so it can be separated by steam distillation. But meta and para isomers, due to intermolecular hydrogen bonding, cannot be separated by steam distillation. Next, looking steric hindrance to intermolecular association by hydrogen bonding may also contribute to lower boiling points. So, if we have two OH groups at meta position or at ortho position, so there will be steric hindrance that it will form less intermolecular hydrogen bonding. There is steric hindrance. So, due to this reason, the molecule may have lower boiling points. So, in this case, there is no intermolecular hydrogen bonding due to steric hindrance, so it has lower boiling points. Phenols generally are now the next property is solubility. It was about melting points and boiling points. That is ortho isomer have low boiling point due to intermolecular hydrogen bonding, and meta and para isomers have high boiling points due to ortho isomer have intramolecular hydrogen bonding and it has low melting boiling points, but meta and para isomers have intermolecular hydrogen bonding and they have high boiling points. The next property is solubility. Phenols are only sparingly soluble in water, but solubility increases with an increase in the number of hydroxyl groups. If on benzene ring more hydroxyl groups are present, then solubility will increase due to more number of hydroxyl groups. They will form more hydrogen bonds with water, and this effect is offset by the symmetry of molecule which helps them to stabilize by themselves. कि अगर मॉलिक्यूल के अंदर ही इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग होगी, ऑर्थो आइसोमर होगा, तो वो लेस सॉल्युबल होगा वाटर में बिकॉज उसमें इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग हो जाएगी. लेकिन जो मेटा और पैरा आइसोमर्स हैं वो वाटर में मोर सॉल्युबल होंगे क्योंकि उनकी इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग है. तो करेंगे resorcinol has solubility of 123 gram per 100 ml of water at 25 centigrade. Resorcinol is meta dihydroxybenzene. When two OH groups are present on meta position, so 123 gram per 100 ml of water at 25 degree centigrade ये soluble है. जबकि जो हाइड्रोक्विनोन है पैरा आइसोमर है इज ओनली टू soluble to the extent of 8 gram per 100 ml of water. जो पैरा आइसोमर है वो सिमेट्रिकल है, जो मेटा आइसोमर है वो सिमेट्रिकल नहीं है. पैरा आइसोमर ड्यू टू इट्स सिमेट्री लेस सॉल्युबल होगा वाटर में। एंड फिनोल जो इटसेल्फ है, ये ऊपर भी आपने पढ़ा है कि ये 9.3 ग्राम पर 100 ml ऑफ वाटर में सॉल्युबल है एट 25 डिग्री सेंटीग्रेड। नेक्स्ट इसका रिवर्स बताया गया कि वाटर इज soluble इन फिनोल टू द एक्सटेंट ऑफ 29 ग्राम पर 100 ग्राम ऑफ फिनोल। एंड फिनोल एंड वाटर आर मिसिबल इन ऑल प्रोपोर्शंस अबव 65 सेंटीग्रेड के। अगर हम टेम्परेचर 65 तक इंक्रीज कर देंगे तो फिनोल और वाटर कंप्लीटली मिसिबल हो जाएंगे एक दूसरे में, बट लो टेम्परेचर पे इनकी सॉल्युबिलिटी कम है। स्मॉल अमाउंट ऑफ वाटर अगर हम ऐड कर देंगे तो मेल्टिंग पॉइंट उससे फिनोल का डिक्रीज हो जाएगा। वैसे जो फिनोल सिंपल फिनोल है उसका मेल्टिंग पॉइंट होता है 42 सेंटीग्रेड, तो अगर हम उसमें वाटर थोड़ा सा ऐड कर देंगे तो मेल्टिंग पॉइंट और भी डिक्रीज हो जाएगा। इसलिए वो कह रहे हैं कि जो सिंपल फिनोल है वो एज अ सेमी लिक्विड प्रेजेंट होती है, क्योंकि अगर उसमें कुछ थोड़े से भी वाटर वेपर्स प्रेजेंट होंगे तो उसका मेल्टिंग पॉइंट 42 से भी लो हो जाएगा, इसलिए वो हमें सेमी लिक्विड फॉर्म में नजर आती है। 5% वाटर प्रेजेंट होगा तो वो completely लिक्विफाई हो जाएगी। एंड लिक्विड्स फॉर्म ऑफ फिनोल जिसमें 5% वाटर प्रेजेंट हो बच्चों, दैट इज नोन एज कार्बोलिक एसिड, विच इज यूज्ड एज अ डिसइंफेक्टेंट इन हॉस्पिटल्स। मेनली जो स्मेल होती है वो इसकी वजह से होती है, कार्बोलिक एसिड यानी वो फिनोल ही होती है, उसमें 5% वाटर उसका सोल्यूशन बना के तो उसको यूज करते हैं, तो उससे जो जर्म्स हैं वो सारे किल हो जाते हैं। So it was all about physical properties of phenol. Now, one property is left behind, that is acidity of phenol, that we will discuss in a separate lecture.